In our third part of section 1.6, I have just some final comments. Watch out for the goofy stuff. So anytime you have a negative, once you've isolated the absolute value, or a zero, that's some goofy stuff. So what we're watching out or calling goofy is either negatives. So negative quantities on the right side, or zero on the right. So anytime I have that, I'm going to stop and think about what it's saying before I just go solve it blindly. Because a lot of times when you solve it, you forget to check it. So example 10 starts off with the absolute value. 2x is less than a -6. So most of the ones we solved had a spare term over here. That's not the goofy stuff. What's goofy over here is that we need to be smaller than a -6. So how can my distance from 0 be smaller than a -6? So smaller than a -6 is a number that's to the left of it. You can't be a distance that's negative. So this one, because of that negative on the right side and the less than, is a no solution. So this one can't be solved. There are no numbers that are going to make that statement ever be true. Goofy stuff. So example 11, we have the absolute value of 3x is greater than 0. Okay, well, at first glance, this one's perfect because we need the absolute value, that distance, to be larger than 0. Distance larger than 0. Well, that would pretty much work no matter what. So at first, we're going to think that we basically have the entire number line. So negative infinity to infinity. But we have a problem. So we'll say, however, what happens if x is 0? So I'm just going to check that, right? So when I plug 0 back into this, I'm going to get 0 on the left side, and 0 is not greater than 0. So we actually need to exclude 0 as a value here. So our answer then would be negative infinity to 0, then a parenthesis to exclude it, start again at 0 and go off towards infinity. In other words, on a number line, we're saying if here is 0, it's an open circle. It's the only number we cannot use. Now, the original statement, hopefully you can see the blue. If the original statement was a greater than or equal to, then our answer would have simply been all real numbers or negative infinity to infinity, because then 0 works. But because there was an excluded value at 0, we had to exclude it. So again, sneaky, stop and think about what it's saying before you just blindly go solve it. Okay, example 12. We have a negative absolute value of 1 minus 2x is greater than or equal to -3. So again, at first I would stop and think about this and say, wait a minute, I got a negative over on this side. So I know we have problems, but I also have a negative on the left side. So according to our beginning definition, the absolute value is not isolated. So that's our first thing. We're going to come in and divide everything by this -1 over here. And because it's an inequality and we're dividing by a negative, we need to make sure we do that flipping. So now what we have is the absolute value of 1 minus 2x is less than or equal to a +3. And that we can solve. So we'll go ahead and do that one last time. So we have 1 minus 2x less than or equal to 3. Immediately write that second statement. Otherwise, you forget to do it. 1 minus 2x is greater than or equal to -3. And we'll solve both of those. So moving the 1, we're going to think, moving the 1 gives me -2x is less than or equal to 2. We're going to divide out a negative again and end up flipping the inequality again. So x is greater than or equal to a -1. Same process over here. If we move the 1, we'll get -2. Dividing out the -2 is going to give me x. Flip the inequality because you divided by a negative is less than or equal to 1. So we inverted the inequality or reversed it to begin with, and then we had to do it again. So there's a lot of flipping. So make sure that they both point either in the same direction. I'm sorry, make sure they don't point in the same direction. You need one of each, basically. Okay, what do we got going on? Well, we have a -1 and we have a +1. And in this case, they're both, oh, it looks like I made a mistake again. If I move that, that's a -4. I did. It's a good thing I'm checking my answers. You guys are yelling at me again. Thank you for catching my mistake. So if I move the 1, it's a -4. I need to slow down. Dividing by the -2 is going to be a +2. Okay, so now we can go to number 1. So we have the -1 from the first solving process, and we have the 2 from the second one. So again, sorry, when I moved that 1, I was doing it in my head. Sometimes getting too much of a hurry, just like you guys. We'll need closed circles. Closed circles. What do we got going on? This is asking me to find numbers that are larger than -1, which would be to the right. This is asking me to find numbers that are smaller than 2, which would be to the left. So again, we're trapped between the two. So then our answer would go from -1 to 2. And there it is. And that's how you solve equations with absolute values and inequalities with absolute values.